Welcome to Mrs. Martin's math class online. You guys can come up with a catchier title for our online YouTube math class. I'd love to hear it. Please share those in our discussion on Schoology. It'd be cool if we can get a fancy intro so we can become YouTube famous. But all joking aside, today's lecture will be notes on our introduction to systems of linear equations. So I highly suggest you get some paper out in front of you and you follow along with the notes. This is an attempt to support you in completing your math homework today. Okay, so let's go ahead and get started. So again, these are notes. It is our intro to systems of linear equations. All right, so in this intro, we're going to start off with an example. So we're going to talk about two people. We're going to talk about Jim, and we're going to talk about Sally. Okay, and in honor of Brandon, shout out to Brandon, period 6, Jim and Sally are going to be collecting Pokemon cards. All right, so in their endeavor to collect Pokemon cards, Jim starts out with 2 Pokemon cards. We're starting out small here because Pokemon cards start to get pretty expensive. And then every day, Jim's going to get 1 more Pokemon card. All right, so an equation to represent Jim's Pokemon card collecting habits could be y equals 1x plus 2. 2 being our starting value or y-intercept, and 1 being our pattern or our slope. Okay, this is kind of a review of our last unit. Okay, graphing equations. We're still going to be doing that throughout this unit. Okay, so there's Jim. Let's go ahead and graph Jim's card habits. Okay, he's starting with 2 cards. And then we're going to do a little pink line to show his slope, which is 1/1 here. Here's my little triangle that we kept drawing in class. Okay, so I'm going to go ahead and draw dots here to represent my rise over run. So up 1 to the right one, up 1 to the right one. I can do a few of these if I'd like. Okay, to graph Jim's pattern. Now, I'm not going to graph on the negative side of this axis because we're not looking back in time, right? Because X we're going to consider, let's say Jim collects cards every day. Okay, so X is time in this situation. Let's go ahead and write that in black. So X time. Okay, and Y are our cards. Okay, and so now there's little Sally. Sally started out with 0 cards. Okay, she wasn't really a Pokemon card collector, but she decides, you know what, I'm going to spend money and I'm going to get a bunch of cards at once. So for Sally, every day, she's going to collect 3 cards. Okay, those are going to start to add up. So she starts at 0. That's her starting value. Y-intercept. And her pattern now is plus 3 cards every time. And just to kind of recap, I didn't write this for Jim, but rise over run, right? That's how our slope would look, rise over run. So let's go ahead and write in Sally's cards. So here she is starting at 0, no cards. And then all of a sudden, bam, she gets 3 cards in 1 day, 3 cards, 1 day passes, 3 more cards for another day. Okay, those are her triangles. And I can draw the other lines. So there they are, my lines for Jim and Sally. So what does this have to do with systems though, right? Because graphing lines, we've done that already. Well, systems, a really special thing is happening for systems. First of all, this is a peculiar point. This point where both lines cross each other. This point in this example is 1, 3, okay? And systems are pretty much this. Systems are this process of having 2 linear equations in general. In our case, they're linear. and being able to find common solutions for them. And in this case, the only solution that's common for both of them is 1, 3. And what does 1, 3 mean? Now, 1, if you guys recall, 1 is days, and 3 is cards. So what does that mean? Well, for Jim, that means after 1 day, Jim has 3 cards. Okay, what does that mean for Sally? For Sally, it means that after 1 day, Sally has 3 cards. So what does that mean for a system? Ultimately, for systems, that means after 1 day, both have the same number of cards. 3 cards to be precise. Okay, so systems are looking for this commonality in 2 different equations. Okay, and that only happens on day 1, where both Jim and Sally have the 3 cards, and then after that, Sally starts collecting cards way faster than Jim does. We can really see that by how steep her line is and how large her slope value is. Okay, all things that we learned last time, it's just now we're combining what we know into a system of 2 equations. So let's go ahead and take some time and look at some specifics for systems of linear equations in this introduction. Okay, we're going to start with some definitions here. So let's start with a definition of systems of, let's be specific, we're going to talk about linear equations. And a system of linear equations is technically a set of 2 or more linear equations. Okay, that's the basic definition of a system of linear equations. Okay, now for Algebra 1, we're focusing on only having 2, but when you guys move on in math, eventually there could be 3, and it starts to become a little more complicated with extra variables. But for now, we're sticking with 2, and when we have 2, we have 3 possible solution sets. Okay? The first possibility is the Jim and Sally possibility, having 1 solution. Okay, and we've seen this before when we talked about solving equations, except that this time our solution isn't just going to be 1 number, it's going to be an ordered pair. So let's draw this example. Let's say we've got some line going through there, and let's do another line going through here, and my 1 solution would be this point where they cross, and you'll have some XY ordered pair. Okay, that's my 1 solution. So now when I'm asking for answers in homework and I'm asking for solutions, you're giving me an ordered pair. Okay, so that's one possibility when you have a system where they just cross each other. Now, in absolute value equations, we had 2 solutions. For linear equations, that's not going to really happen for us because these lines have to be straight by definition. So they can't just turn around and cross each other again. So when we have 2 lines that cross each other, they will only cross once to yield this 1 solution. Right, now there is another possibility. It is possible that we have the situation where we have no solution. Again, just like when we used to solve equations at the beginning of this school year. And what does that look like? Well, you've actually seen this already. Some of you did this when we did the candy activity in class, where we had 2 lines that had the same slope. Now, if they're changing the same and they have the same slope, that means they're never going to cross each other. They will never meet the way they met for 1 solution. we had a name for this in class. We called these parallel lines, and they had the same slope. Okay, and when this happens, they never cross again, so they have no solution. There's never a time where there will be a point that satisfies both lines at the same time, okay? And finally, there is the possibility, you might have guessed it already if you remember your equation stuff, that we have infinitely many solutions. Now, what does that look like? That looks a little different, and I'll try to use a thicker pen here. Infinitely many solutions is, for example, the case where we have some line, okay, and then we have a second line graphed right on top, okay? Now, technically what that means is that it's got a bunch of points that all match up. So many points, in fact, that it creates a line itself. And since all the points are shared, then that means all the points are solutions, and hence infinitely many solutions. Okay, so these are the three possibilities for solution sets for our systems of linear equations. Now let's look at some things that you'll probably see on your homework today. Let's do another example together. And we're going to say y equals negative 3x plus 5. And then for this next one, I'll say negative 4x plus 6. Okay, there's my system of equations, two linear equations. And it's going to be very important that we can graph these. Okay, now in your homework, they're going to ask you two things. First, they'll ask you, is 0, 5 a solution? Okay, now you've done this already for the solving equations or solving linear equations unit, where you had to plug in numbers to check if it was true. Now, when we were doing that, we only checked for one equation. Now for systems, we just have to make sure that we check both. Okay, so I'm going to start with this one, and I'm going to use blue. Okay, so y equals negative 3x plus 5. Okay, and then I'm going to use green for the second function, y equals negative 4x plus 6. Now I'm going to be very careful here. We got to remember that these ordered pairs represent an x value and a y value, an xy pair. So let's go ahead and do all of our x's purple. And I'm going to go ahead and highlight all of my y's yellow, just to help us keep track of where everything's supposed to go. And so now I can carefully write these in. So 5, let's start with this blue equation over here on the left. 5 equals negative 3 times 0. I use parentheses to show I'm multiplying. And I just want to see, I substituted x and y, and I just want to see, is this equation going to be true? So I'm going to carefully do some math here. Nothing's happening on the left, so that's just 5. Negative 3 times 0 is 0. 0 plus 5. So now I've got 5 equals 5. And I know from my training last semester that 5 equals 5 means true. So far, so good. This is a solution to one of the equations. Now the question is it a solution to both? It's very important that we check both equations. All right, so now I'm going to go ahead and take that 0, 5 pair, and I'm going to check it in this green function. So y was 5, x was 0. I'm using parentheses again to show multiplication. And then I get 5 equals 0 plus 6. 0 plus 6 is 6. And then I end up with 5 equals 6, which makes no sense. So I know this is false. And since I have one false, that means 0, 5 is not a solution to the system. Okay, because one of those was false. Now let's go ahead and see, well, if this is not a solution, then what is the solution? So another part of your homework will be to ask you, what is the solution, or how many solutions will I have for this system? Now, in the future, we're going to have 3 different ways of doing this. Right now, we found out one way. We've got a graphing method. Okay, that's the one we already know. We know how to graph. We learned that already. Graphing method, we know. We just did with Jim and Sally. Coming up in future lectures, we will be doing substitution, which is hopefully a familiar vocabulary word for you. And then we will be doing something called elimination. So just be aware that there will be 3 different methods, and right now our focus is graphing. So let me import another image here. Okay, and I'm going to bring in a coordinate plane so we can graph this nicely. You guys have graph paper, I strongly recommend using that. Okay, and I'm gonna go ahead and drag this over here, make it a little larger so we can work on it. Okay, and I'm gonna graph our functions. Let's start with blue. We had a positive 5 with a slope of -3, 1 over 1, right? -3 over 1. I can do that a few times to get a few good dots, and I'm going to carefully graph this line. Okay, there's the blue one. Now I'm going to go ahead and graph the green one. And again, this is all just review of graphing lines. If you're not too sure about it, make sure you get some practice in. And I start at 6, and then I'm going to go to -4 to the right 1. So down 4 to the right 1. I'm building my lines, and those are pretty close, but I can see really clearly from making my dots that my solution is right here. Okay, my solution ends up being at 1, 2. In other words, if I took 1, 2 and I substituted into the blue and the green equation, it's going to come out true for both of them. And I just proved it by graphing them. So what is the solution? My solution is 1, 2. I have one solution. Okay? And so that kind of takes care of our introduction to systems of equations. We'll look at more applications of those, take some time, do some more graphing before we get into substitution and elimination. But I really want to make sure we all understand how these systems are working. And so I have assigned for you some homework via Alex, which will be in the next video on how to access that homework. Once again, as I will continue to remind you on these videos, if you have any questions or comments or suggestions, please post them in our discussion on Schoology, where you saw this video link to begin with. It's a great spot for you to ask those questions so we can share with the rest of the class. When you ask questions, it really helps me see what you need help with, and often my answers help the rest of the class as well. If you're going through the discussion and you see someone ask a question that you can answer, feel free to reply to them as well. I think it's great if you guys can start communicating with each other and not just waiting for me to respond. After all, it does take me a little while sometimes. So I hope you enjoyed the video. I hope it was helpful. And again, any suggestions so that I can make these videos better would be very much appreciated.